Hello, all my friendly math people. Okay, so today begins kind of the second half of trig functions. In the first half, we focused on radian measure, arc length, angles in standard position, building the unit circle, all about trying to find those ratios. If I have an angle, trying to find the angle if I have the ratio. All of that was kind of the first half of trig functions. Okay, now we go into the second half of trig functions, which is looking at the actual graphs and the properties of the graphs. Now, essentially, I have this divided into a few different lessons. Today, we're going to look at graphing kind of part one, where we're just going to essentially talk about two of the four parameters on the equation of a trig function. Now, you can imagine right now what those four parameters are, right? I'm going to take a basic function like y equals sine of x, and I'm going to throw in an a b, an h, and a k. Okay, and those are all going to feel very similar to what you've been doing with transformations all along. The difference now is we often don't use those parameters to describe transformations. Instead, we look at how that affects the shape of the particular graph we're looking at. And I'll talk more about this as we go, but it's important that you don't use transformations to describe the values unless you're giving a base function, okay? If I don't give you a starting graph like y equals sine x, you can't say that this new graph is transformed from something else, okay? Okay, now, and the other thing is it won't be A, B, H, and K, it'll be A, B, C, and D, but it means the same thing, so don't stress about that. The letters never really matter that much. Then tomorrow we'll look at the other two, and then we'll look at trying to create equations from pictures, and then we'll look at applications, and that'll kind of finish the unit, okay? So this is the second half of trig functions. In total, if you want to think of trig, the big word trig in 30-1, kind of have it divided into four sections, okay? The units are trig functions and trig equations. Then inside there, so inside trig functions, we have that first half on angles and radian measure, and the second half on graphing. In trig equations, we kind of have the first half on solving equations and the second half on identities. Okay, so that's kind of what it all looks like if you're just trying to figure out a big picture here. Okay, I'd like you to grab your calculator, and with your calculator in radian mode and a window settings of -2 pi, 2 pi, pi over 4 for x, and -1, 1, 1/2 for y, sketch the graph of y equals sine of theta and determine the domain and range. Please pause me and do that so that you have a picture before I show you my picture. This is what it should look like. Now, your graphing calculator won't give you the pi and 2 pi as actual exact value, but I've written them in there just so you have an idea of where you are, okay? The domain for this guy will be real. Now, I've already gotten you to graph this, right? We have introduced the graph of a sine function, both for sine theta and cos theta, a couple lessons ago. So this should look familiar to you. I never gave you the negative part of it. I only gave you from 0 to 360 or 0 to 2 pi, but it should still look familiar to you, okay? You can see that this pattern, though, is going to continue forever and ever and ever. So the domain of this guy will be real, and the range will be from -1 to 1. Okay, so now let's try cos. Same window settings, just change your graph to y equals cos of theta, please. Okay, and you should have gotten something that looks like that. But again, same domain and range. And if you were paying attention when I first introduced these graphs, I made the comment that there really isn't a whole lot of difference between a sine graph and a cos graph, with the exception of one has been shifted left to the right of the left or right to the other guy. Okay, that did not come out well. One has been shifted left or right of the other guy. Okay, aren't you guys glad I don't teach you English? Okay, good. So the domain will still be real, and the range will still be between -1 and 1. If you want to write that in interval notation, that's great too. Okay, now this is not in your book. I just want to paint a quick little picture here for you of where we're going. So we're going to take that y equals sine of x, and we're going to create y equals a sine of b, x minus c plus d. Your old h is now c, and your old k is now d. That's totally fine, okay? They all do the same thing, but in trigonometry, there's a little bit more vocabulary that we talk about, okay? Because we don't always say we're comparing it to this base function of y equals sine of x, okay? So your a, actually, I'm not going to talk about a yet. I'm going to talk about d. So I want you to notice that red line that I just stuck up there, okay? That red line is not actually there, but what if I put it in, you can see that it's kind of right in the middle of the graph, okay? The graph kind of comes above that line and below that line, but you can kind of see that it's equidistant from that line, okay? So that's kind of the line in the middle, and so we call it the midline, okay? D is called the midline. Now, if you think about transformations, if I was to move this up or down, that line would move up and down, and the graph would then still be over and above that midline. So D is still your vertical translation, okay? If we're comparing it to y equals sine of x. But often what we're doing is we're just looking at an equation and we're not comparing it to a base equation. And that's why we don't always talk from a transformational standpoint. What I want you to get comfortable with in your vocabulary is to talk about it from a sinusoidal standpoint. That represents the midline. Now I've drawn this solid for you just to make sure it pops out at you. But when you're drawing it, and you should draw it in your graph. If I ask you to draw a graph, you should be drawing it as well. But it should always be a dotted line, just like asymptotes, because they're not part of the function, so we can't draw them as a solid line, okay? All right, so then I talked about the fact in that conversation that the distance from the midline to the top or the midline to the bottom is the same distance, okay? And so that is actually our A parameter. A is for amplitude, and it's the distance from the midline to the max or the min. We could also look at it as half of the range, so it's half the distance between the max and the min, okay? Now, you know from a transformational standpoint that to be a vertical stretch, and it still is. If I was to have an A value of 2, what would happen is this, instead of going up to 1, would go up to 2, right? Oh, let me do a different color since that was already green. That would go up to 2. My zeros would still stay, but then now this, instead of going down to 1, would go down to 2, and you can see that this is how a vertical stretch would be produced. But the A value, oh, that was kind of sloppy right there. Sorry, I'm doing this with a mouse, but the A value there has changed from 1 to 2. Okay, so it still is performing a vertical stretch, but we think about it more in terms of the context of the trig graph, where we call that the amplitude. And the amplitude is the distance from the midline to the max or the midline to the min. Okay. Okay, the next thing I want to talk to you about is the period of the graph. These are called periodic functions. The reason they're called periodic functions is they repeat themselves every kind of certain amount of horizontal distance. Okay, for instance, if I was to just take a look at from this point to this point, okay, what I would see there is this is the distance of one cycle of the graph. You see, I start at the max, I go all the way down, and then I go all the way back up. So that's one cycle of this graph. After that pink line, it just starts doing the exact same cycle again. It doesn't have to start there though. I could have started maybe here. If I drew a line here and I look at that and I see here, that's where I start that cycle again. So at this green line, at the first green line, I started on the midline and I was heading down. Okay, so then I come down, I go all the way up, and then I come back down. And so at this green line, I'm starting at the midline and heading down. So I'm starting in the exact same spot. If you look at the width of the green line and you look at the width of the pink line, they're the same width, okay? And that width is called the period of the graph. The period is essentially the distance it takes for a cycle to happen in the graph, okay? Now, in the equation, so here's the period I gave you from minimum to minimum, okay? In the equation, that will relate to the b value, okay? So the period is the time it takes for one complete interval, horizontal distance either from max to max or from min to min, or I could go, I showed you, essentially I could go midline to the second midline, okay? Now the relationship here is with the b value, and what happens is the period of a graph will be 2 pi divided by b, okay? The period of the graph will be 2 pi divided by b. This is not something that's given to you on a formula sheet, so it is something you should commit to memory, okay? The period of the graph is 2 pi divided by b. Likewise, b would be 2 pi divided by my period, okay? We, just depending on which one we have and which one we want, we can state that in either way. Now, you know b from your transformational mind as a horizontal translation. Sorry, as a horizontal stretch. I should really listen to what I say before it comes out. You know b is a horizontal stretch of 1 over b, right? So take a look at this. If b was 3, and you're going to see this today, you're going to see this visually when we do some of these graphs. But if b was 3, that would be a horizontal stretch of 1/3. Okay, now, think about that with my period. The standard period for sine graph or cosine graph is 2 pi. Okay, so by going 2 pi over 3, because it says 2 pi over the b value, right? Really what I'm doing there is 2 pi multiplied by a stretch factor of 1/3. Okay, so it still works as a stretch factor. It's just that we often are not describing it in terms of transformations. And so what we look at rather is what is the period of the graph. And if we want the period of the graph, we're going to go 2 pi divided by b. I should also mention right at this point, 2 pi is because I'm speaking in radians right now, okay? If this graph was based in a degree scale for x, it'd be 360 divided by b, okay? All right. So the one thing I haven't talked about in this kind of introductory conversation yet is C. We'll deal with C more actually tomorrow in the next lesson. But C is, from your transformational knowledge, you would know C would shift it left or right, okay? And that's what C is doing here. I know we call it H when we were talking about transformations, and now we're going to call it C. Not a big deal. We're also going to give it a new vocabulary term. It's going to be called a phase shift, okay? But C does exactly what you think C would do. It would shift it either left or to the right, okay? All right, so we're just going to quickly summarize what we've talked about here with all of this new vocabulary. So sine and cosine graphs are known as periodic or sinusoidal functions, okay? Periodic just means they repeat every particular cycle, and that cycle is known as a period. They repeat the same cycle in set intervals. The important points that we analyze in a sinusoidal graph would be your maximum points, your minimum points, and then your midline intercepts, okay? Remember the midline intercept was that D value. So where is the graph hitting that D value each time, okay? So when we're trying to draw the graphs, when I'm marking you on your drawings, I'm going to be looking for accurate maximums, accurate minimums, accurate midline intercepts, and then I'm going to be looking for a nice curve that connects those, okay? Okay, so the midline is your D value, and that's the horizontal line in the middle of the graph that the function rises and falls from. When you go to draw your own graphs, you would draw the midline in as a dotted line, much like you would an asymptote, because it's actually not part of the function. It's not, it doesn't actually exist, but we use it as kind of an anchor for the rest of the graph, okay? So just like you would draw asymptotes in as dotted lines, you're going to draw your midline in as a dotted line as well, okay? The d value is also known as your vertical displacement. From a transformational standpoint, we think about how far up or down we move the graph of y equals sine x, right? If y equals sine x was our base function, if I say y equals sine x plus 2, then I took the graph of y equals sine x and I moved everything up 2, okay? So that vertical translation aspect in the realm of sinusoidal graphs or periodic graphs, we call that the vertical displacement, okay? The midline is the average of your maximum and minimum value. So if you know your max and you know your min, you can take the average and that'll get you your midline. Well, how do I take the average? You add the two pieces together and then you divide by 2, right? Mathematically, to take the average, you add all the things together and you divide by the amount of things you added together, okay? In this instance, it would be 2 because you've got your max and your min, okay? Okay, cool. Your amplitude, that's the distance from the midline up to the maximum, or it's the distance from the midline down to the minimum, okay? So the amplitude will be half of the distance from the minimum to the maximum, okay? So essentially it would be half the full height of the graph. That would be your amplitude, okay? And that would look like that green one that I've just put in there, okay? So I've shown it to you going up or going down, okay? Actually, I'm just gonna hide my head here for a second just to make sure you can see what I've done there. So the red line here is your midline, and then the green line is your amplitude, okay? All right, the period is the horizontal distance it takes to do one complete cycle of the graph. The standard period for a sinusoidal graph is 2 pi, if we're talking radians, or 360 degrees if we're talking degrees. And the relationship between the period and the b value is period equals 2 pi over b, okay? And that is not given to you on a formula sheet. That is something you do need to know, okay? So the purple line that I've drawn in there, I've shown you from min to min, but you could also go from max to max, or you could go from midline to the second midline, and that would be a period. Okay, again, your period is not the b value, but it's related. What happens is b value will be 2 pi divided by the period, okay? Okay, and then the phase shift. Essentially, the phase shift is a horizontal translation, and it's our letter C. The phase shift moves the graph left or right of the original function. And as I said, we'll deal with that a little bit more when we get into tomorrow's lesson. Okay. So our focus today is going to be on the A value and the B value. So we're going to kind of hone in on the A and the B, and then tomorrow in kind of part 2 of this, we'll throw in the C value and the D value. And then at the end of tomorrow's lesson, we'll also start playing with everything together, okay? Okay, so the first thing we see here in your book, below is the graph of y equals sine of theta. Using your transformation skills, okay, so y equals sine of theta is going to be your base function here, and we're going to compare the base function to a few other functions, okay? It's important to note, if I said y equals 2 sine of theta, I can't just say that that's a vertical stretch of 2, okay? It's not a vertical stretch of 2 unless I say compared to the base function of y equals sine of theta. So in these questions here, because we want you to think about them from a transformational standpoint, we are establishing the base function as y equals sine of theta. And now we're going to ask you to use your transformation skills and compare the graphs below, graph the new functions, and determine any invariant points. First thing we want to do is fill in this information for just that base guy, y equals sine of x. So the midline here is 1, okay? If I was to go from, sorry, the midline, I was talking about the amplitude. The midline is at y equals 0 right here. Okay, that's the line in the middle. The amplitude is 1, because from the midline, I'm going up 1, or I'm going down 1. Okay. The period, the time it takes to do one complete cycle, well, I can start here and then I start again here. So that distance is 2 pi from there to there, okay? My domain will be real. My range will be -1 to 1. My y-intercept will be 0, 0. And my x, or my midline intercepts actually right now, My midline intercepts will be at this guy. Actually, let me take the ink off and start again here. My midline intercepts will be here and here and here and here and here, right? There's an infinite amount of midline intercepts. So I want to bring you back to a couple days ago where we talked about the general form of coterminal angles. Essentially, this is going to look the same. What we do is we state our first positive plus the period of repetition. Okay, so for this guy, now humor me for a second because I just want you to get the visual. My first positive is 0, so I'd say 0 plus, this is happening every pi. Every pi, I'm going to get a period or another midline. So I'd say 0 plus pi n, where n is a member of the integers. Okay, now, nobody says 0 plus, right? So we're not actually going to say that. I just wanted you to start with that form so you can see that form. If we had started on like pi over 4 and then we added pi n, we'd go pi over 4 plus pi n. But because it's 0, that's kind of special because nobody ever says 0 plus. So we're not actually going to say this part. We'll take him out and we're just going to leave it as pi n, where n is a member of the integers. Okay. So if you don't see that starting guy, you know that that starting guy is actually 0. Okay. All right. Good. So here we go. We've got everything filled in for the first guy. Now, for the second guy, I'm introducing an a value of 1/2. So based on the conversations that we just had and based on your knowledge of transformations, you should get comfy to say, hey, at this point, I'm only going to go up to 1/2 now instead of going all the way up to 1 because my a value is 1/2, but also because I'm vertically stretching it by 1/2. So I'm kind of compressing it like that. The zeros will stay where they are. So I'll have those guys because 0 times 1/2 is still 0. But then I will also only go down to 1/2. So I go up to 1/2 and down to 1/2. So you can see if I connect these dots like that, I'm going to get a graph that looks like this. Okay. Now, the only thing that changed in those parameters is actually what my a value was, what my amplitude was. So the midline is still at 0. The amplitude is now 1/2. The period hasn't changed. And it shouldn't, right? Think back to transformations. The period would involve a horizontal item, right? It's a horizontal distance. Doing a vertical item shouldn't affect a horizontal item. The domain will remain the same. It's still going to be a member of the reals. The range now changes from -1/2 to 1/2. Y-intercept stays the same. Midline intercept stay the same. Okay. All right, now we're going to try y equals 3 sine of x. So now instead of, I'm just going to get the right color here. Instead of going up 1, we're going to go up 3. So my max is now going to be there. My midline, sorry, are still the same, right? But now my max goes up to 3, and my min goes down 3, which is right there. Okay, so you can foresee that graph looking like that if you can follow my mouse there. Okay, I don't really want to draw it in freehand right now because I'm going to do a super bad job of it with a mouse. So much easier if I'm holding a pencil. Okay, but let's just talk about the parameters first before I show you the picture. So the midline hasn't changed. The amplitude will now be 3. The period won't change. The domain won't change. The range is now going to be from -3 to 3. The y-intercept won't change, and the midline intercepts won't change. So this is what you should have for this guy. Okay. All right, cool. Okay, let's try -3 sine of theta. So now the 3 is still the same, the amplitude is still the same, but I put a negative, so I've essentially put a vertical reflection. So where I had, okay, sorry, I was just trying to get the right color again. Where I had this guy at 3, he's now going to come down to this guy at -3. Where I had this guy at -3, he will now come up to this guy at 3 because everything will be reflected. The midline intercepts still won't change because those would be invariant points on a reflection. Okay, so my midline will be 0. My amplitude will be 3. We don't say an amplitude is -3, just like we don't say a stretch is negative whatever, okay? So the amplitude will be 3. The period will remain unchanged. That'll be 2 pi. The domain also doesn't change. That'll be still -infinity to infinity. The range will be going from -3 to 3. The y-intercept hasn't changed, and my midline intercepts haven't changed. Okay, so just verify all of that, and your picture will look like this time, which is a reflection from the green graph. Okay, so now what you want to do, or what you should have done, is you should have graphed all of those on one guy. So if you did that, your graph maybe doesn't look as pretty as mine because it might not be in different colors, but those were all the graphs that you just drew, okay? All right, so now we're going to shift our focus and we're going to talk a little bit about the b value, okay? And the b value changes the period, right? Because we said that that relationship was period equals 2 pi divided by b. And we're going to graph a few of these and show you how that happens, okay? So the first guy I just put right in because it's the same base function from the last question. Okay, so we're starting with sine of theta, midline, amplitude, period, domain, range, y-intercept, midline intercepts, all stated for you because we've already stated them. Now, we're going to take a look at y equals the sine of 3x, or 3 theta, sorry. Okay, so what is my new period? Well, my new period will be 2 pi divided by 3. Okay, so when we do this, you always got to think about how many tick marks it takes to get to pi. So if I count this right now, I'm 1, 2, 3, 4, 5, 6 tick marks to pi. Okay, that means every tick mark is pi over 6. Okay, it took me a regular period of 2 pi. So the regular guy is 2 pi. My new period is going to be 2 pi over 3. Well, if I want to convert that to tick marks being pi over 6, 2 pi over 3 is the same as 4 pi over 6. Okay? So a new period, look at this, 1, 2, 3, 4. That's where my new period will start, at 4 pi over 6. Okay, because my new period is 2 pi over 3, and 2 pi over 3 is the same as 4 pi over 6. I'm just trying to convert it to the tick marks that I have in front of me, so I can kind of count the tick marks. Okay, so where you see this whole period, starting at the midline, going all the way up, all the way down, and then all the way up again, that whole thing has to now happen in this distance from here to here. So everything's gonna get smaller width. Now, if I keep the same window, that means I'm gonna see a whole lot more periods in this window, right? It's kind of like I'm taking an accordion. I don't know if you guys even know what an accordion is, but it's an old school instrument, but it's like taking an accordion and squishing it together, okay? So all those flaps would come closer and closer together, okay? So that's gonna change a lot of things for us. Now, how did I graph that? I wanna just take a couple minutes here to help you feel comfortable about where that graph came from, okay? So what I want you to notice, if I just gave you this guy, and actually let me divide it up in the same way. Okay, so this was my original guy where I have 1, 2, 3, 4, 5, 6 tick marks to pi. That was my original fellow. Okay, and now I'm saying that everything has to happen 4 tick marks away. Well, 1, 2, 3, 4, that means that's where my new period will be. When you're drawing these graphs, what I want you to think about is all the important points. The important points are the midline intercepts, the maximums, the minimums, like that. Okay, and what I want you to notice is that actually when I plot all those those important points, it actually divides into 4 sections. Okay, and those sections are all equal to each other. Okay, so essentially what I do is I take that period that I have and I'm going to divide it into 4 sections, because if I can divide it into 4 sections, then I can plot these super easy. Okay, so I'm gonna go 1, 2, 3. Now it's only 4 tick marks for a full period. So if I divide that by 4, every important point is happening 1 tick mark away. So at 1 tick mark away, I'll now be at the max. 1 tick mark away, I'll now be at the midline. 1 tick mark away, I'll now be at the minimum. And so that's where this new shape comes from. And then I just keep going. Okay, so how did it affect the parameters? Well, it didn't affect the midline. It didn't affect the amplitude because it wasn't the amplitude. The period, we've talked about how it affects. The period is now going to be 2 pi over 3. Doesn't affect the domain and range. It doesn't affect the y-intercept. It does affect the midline intercept. So again, I just want to have a quick conversation around those guys. Okay, so in the pink graph that I've drawn up here, which is the same as the red graph on the screen, I just thought it might be a little easier to see one period of it first. The first midline intercept is at that 0 again, okay? Don't ever do this, the 0 plus. I'm trying to teach you the format, and then we'll simplify it in a sec. So it'd be 0 plus the period of repetition. Well, the period of repetition is 1, 2 tick marks, I'm there again on the midline. 1, 2 tick marks, I'm there again on the midline. So you can establish that you're hitting the midline every 2 tick marks. Well, what did I say 1 tick mark was? 1 tick mark is pi over 6. So if 1 tick mark is pi over 6, 2 tick marks is 2 pi over 6 or pi over 3. So I'm going to go 0 plus pi over 3n, where n is a member of the integers. Now, nobody said 0 plus, so my midlines will occur at pi over 3n, where n is a member of the integers. Okay? All right. Let's try this guy. Oh, actually, I want to go back to this for 1 sec. From a transformational standpoint, okay, if I introduced a b value of 3, that should have created a horizontal stretch of 1/3. So it should look like this, okay? I know I've already talked about it looking like that, but I want to relate it back to transformations. That is what a horizontal stretch of 1/3 should have done, okay? So again, I just want to try and slowly connect the transformations that we know with these new parameters on a trig graph, okay? All right, so now we're going to try sine of 1/2 theta. So now my b value is 1/2, which means it's a horizontal stretch of 2, okay? From the perspective of a period, my standard period is 2 pi, and my new period, well, my new period will be 2 pi divided by b. Well, 2 pi divided by 1/2 is the same as saying 2 pi times 2 over 1. So my new period is 4 pi. Okay? That means everything's going this way instead, right? It's gonna, instead of doing 1 complete cycle in 2 pi, I have 4 pi to do 1 complete cycle. So everything's gonna get stretched out this way, which is exactly what should happen if I have a b value of 1/2. Okay, so midline, it won't affect. Let's try and do this without the picture. See how you're doing. Okay, the midline won't be affected. Amplitude won't be affected. The new period will be 4 pi, and we just had that conversation. The domain won't be affected. It'll still be a member of the reals. The range won't be affected. The y-intercept won't be affected. The midline intercepts will be affected. Now, I don't know if you've caught that the midline intercepts are happening every half a period, okay? If you think about the regular sine of theta, the period was 2 pi, and the midline intercepts are happening every pi. In this last one that we did, the period was 2 pi over 3, and the midline intercepts are happening every pi over 3. You see that? The midline intercepts are happening every half of whatever the period is. So for this guy, if my period is 4 pi, the midline intercept should be happening at 2 pi n. Okay? And then when you go to draw it, okay, I will draw this on the screen for you, I think. So I think this one's probably easier than the last one I gave you. Let's go pick, what color am I wanting to do? Oh, I'm going to do green. I'll match what I'm, isn't that fun? Okay, so here's my start. Here's my end. Remember I said that all those important points that I showed you on the board back there, divided it into 4. So can I take 4 pi and divide it into 4? Yeah, that's super easy, right? I'll have an important point happening every pi away. So at the first pi, I'll be at my max. At the second pi, I'll be at my midline again. At the third pi, I'll be down at my minimum. And we can see that that's now going to look like, I told you I wasn't going to do this. Okay, there, something like that. Okay, and then I'd repeat that pattern on the other side as well. So you should get a drawing that looks like that. Okay? You feeling okay? This is a lot all at once. I totally get that, okay? You have to remember, between today and tomorrow, it's 2 lessons to try and really get comfortable with how all of these graphing parameters work. Okay, then the last guy, I'm going to throw in a negative on my b, but we already know that that would just cause a horizontal reflection. Okay, so think through the green graph I just showed you. Let's just go back there for a sec. If I do a horizontal reflection, okay, this, I just need to change color, sorry. So this guy is at negative 3 pi, so he'll now be at positive 3 pi. This guy's at pi, so he'll now be at negative pi, right? This guy's at negative pi, so he'll be at positive pi. This guy's at 3 pi, so he'll be at negative 3 pi. And then I can see, if I connect these guys, there we go. Something that looks like that, okay? Again, my arm is not steady there with the mouse, but that's where we're going. So will it change any of these parameters? Actually, no, right? All of those parameters will remain the same when I do the horizontal reflection. So it'll look something like this, okay? Okay, and then if you put all that together, which I assume you've done, you have this mess of a drawing on your thing that looks something like that, okay? All right, that's all we're doing for today. I think that's enough to wrap your head around. Please take your time with this. Please draw carefully and think about all those important points, okay? So your important points are the midlines, the maximums, and the minimums. And they're always a quarter of a period away from each other, okay? We're going to pick this conversation up tomorrow with, so tomorrow we're going to add in a C value and a D value. And then we'll be graphing with all 4 of them as well. So we'll just learn how, right from an equation, how to produce an accurate, nice sinusoidal graph, okay? But this will keep you busy for now. And if you have any questions, make sure you connect with me, okay? Awesome job, guys. We'll see you next time.